Well, hi, good morning. Welcome to my shop. Today is September 29th. And what I'm aiming to do today is work on these, all the capacitors that are down in this area of the radio, and clean them out basically, and replace them all. Just before I get going on that though, I want to take a closer look at what the last repairer did up in here. So let's take a look with another camera here. So there's something a little bit unusual looking here, that's for sure. I may have kind of pointed this out on another video. It's got three capacitors coming up here, tying together, and then catching a wire and heading down to what I realize is a grounded terminal or grounded spot. So this is chassis ground on top of these. This is certainly not how this radio was built originally, and they would never make anything like this. So in looking at it very carefully, I can see, which you probably can't, well, if you look at this capacitor here, the lead going down the back goes down and solders solders to the frame of the switch assembly here. And you can see the same sort of solder points down under here, two of them, but the wires are gone. So almost certainly that's where two of these capacitors went. One here, somehow. The third one, I'm not sure where it went. Also, it would have gone to some ground terminal, so there's probably lots of convenient locations. Why the fellow chose to do this? I thought about this for quite a while. And I concluded he chose to do this because it was his solution for using used capacitors, which he had cut the leads off. So I'm going to guess these capacitors came out of other radios. That's where he got them. And he's cut the leads to get them out. The leads are short, and so he's caught. He can't manage to get them back to where they were, and this is his solution for utilizing three old capacitors. That's my theory on it. Now back down in here, get a little light in there. So down here certainly looks like a wax capacitor to me, sitting here, and you can tell if I'm looking at the lead connection, it's either been cut and then reconnected. That could indicate some kind of test being done. But almost certainly it means this one is also a replacement. And if you look right underneath it, there's a reddish colored molded one that is certainly a replacement too. So those are really awkward to get at. This is the most awkward one, this wax one here, because the other end of it is way up inside there. And you know, when I sit down for a meal, I tend to eat the food on my plate that I like the least first. So after I get that out of the way, the rest of it is quite enjoyable. I'm not a very picky eater either. So maybe I'm going to go after this difficult area first and get that dealt with. Yikes. So all told, I think there's 1, 2, 3, 4, 5, 6 capacitors I've seen so far. There might be some more hidden in there somewhere. I haven't noticed yet. I don't think so. 6 capacitors. Well, we'll go after these two down here. Now I've got to make some kind of a plan of action. Let me get in there really closely. This is the kind of work that if you don't think it through or have some kind of plan, and you know about it, you're probably going to find yourself in a jackpot as you try to get through it. So just one sec here. I'm gonna just focus this a little bit better. What I really want to see is that, where's that lead going? And can I get at it from underneath here? So I'm trying to stick my fingers up. I'm looking at that paper capacitor right at the bottom of the screen there. I'm trying to get my fingers to appear. No, there's no way. Just here, let me just flip this for a second. Just so you get an idea. I'm trying to reach up underneath here. No. I can't get my hands up there. I can't get anything up there. So the work would have to be done down through here. Wow. Wow. Oh my gosh. So other alternatives are to remove some of these assemblies. That looks like a disaster in the making if I attempt to remove one of these coil assemblies here. Yeah, I think that would be the end of it if I tried that. Way down there. See, I can't get a cutter in there. I can't. Wow. No wonder he left that. You know what I think he probably did? He probably cut this lead to swing it out of the way. Let's see if I can stay out of the way of the light here. Swing things out of the way. He would have cut these other two also, I guess, but he didn't. Somehow he got that red one down under there. That's an achievement in itself. I can get that one out fairly easily. How's that going to help the situation with the paper one here? Now, how do I know this one's worth all this effort? You know, I don't. Other than, you know, 1937 all the way to today. Man alive. Okay, so I definitely picked the tough one here. I'm just trying to find any alternative to going down in there. Wow. Wow. Okay, let's try sticking some tools in there and see what happens. I got my little tiny cutter here. So believe it or not, I can get this all the way down there. I just can't be sure what I'm cutting. So it looks like I can cut it. And then what? Then oh my gosh, I'd have to, this is a stone cold soldering iron here. I have to get this down here. Oh my gosh. Wow. Well, it looks like it's you know, possible. Barely possible. Here, get this out of here. What's banging here? Am I reaching the wire? No, I'm not. So what's happening is the soldering iron, because it shapes like this, you get hung up on stuff on the way down and make you think you've reached the target when in fact you still got, you know, a couple millimeters to go. That's what's happening here. Now if this broken switch were out of here, I'd have a little more room for the soldering iron. Maybe it's broken switch time too. Why don't we just, let's make a mess of everything. Why not? So this switch is busted. Why don't I take it out of there? You know, I could loosen it off and just swing it out of the way. This is a little stiff here. How much out of the way does it go? Is it worth doing? I mean, like, this thing has to be dealt with at some point anyway. And I don't know what to do about this either. Look at the case cracking there, eh? Hopefully they didn't make airplanes out of this metal. I better reverse my whole plan here and go for the easy ones first. And build up to the big, tough one. Tell you something else I just spotted here. What am I seeing? What am I seeing down here? Let me get in as close as possible here. There's something funny I can see. And I don't mean funny, haha. Let's take a look here. Not the yellow wire, the dark one. Oh my, look at that. What exactly is going on there? Is it going through a hole? No, that's just in contact. Oh my gosh. Look at that. Okay, so I'm going to move this wire and we're going to find something out here. First, take a look. It's bone straight down to there. So it would be pretty sort of stiff and powerful getting down to the bottom of the cabinet here. Oh my, look at that. Okay, let's move it. I'm going to get a pair of pliers in my hand here. Let me just drop the camera for a sec. Drop. Okay. Now maybe somebody else spotted this. I got a comment from somebody saying it looked like they saw a shorted wire, but frankly I thought it was these that he was talking about, and I think it was these. These I've looked at, they appear okay. I'm looking at them again now. But I never noticed this one. This one's not easy to see. This is really hidden. Okay, so the problem here is trying to figure out if that's shorted to the chassis or not. Oh, I see it. I moved it with the camera there. So it looks like it's swinging just above the surface of the... Okay, so I'm gonna move the wire now. Let me just get a hold of it here. Okay. Boop. Okay. And we want to see what's going on the chassis underneath. Come on, move out of the way. Doesn't look like anything. Well, I think this would come into the category of, ooh, that's a close one. I don't think it's actually shorting. You know, given a little bit of moisture there, from humidity and stuff like that, it might. And if this is supporting a high voltage, which it probably isn't, but if it was, it might get a little leaky there. I don't know. Okay, so what I'm going to do with that, I'm just going to bend it away from the base of the... I'm just going to put a kink in that nice straight part, and that'll lift it up. There we go. So it certainly can't be shorted now. Wow, it is definitely bad looking. Okay, so I don't think that was actually shorting, and if it was, it would be one of those intermittent, crackly, very noisy things that'd be really sensitive to banging the cabinet and stuff like that. So I don't think that's our hot resistor, the cause for hot resistors. What am I doing? What am I doing here? I'm all excited about finding that wire. I've lost my head. Okay, change of plan. Since I can't clarify how to get at this difficult one, I'm going to go for the easy ones and work my way up. Okay, so I'm going to leave the lousy stuff on the plate till the end of the meal. It's just going to leave a bad taste in my mouth when I'm all done. Well, let's go for Mr. Easy first. Mr. Easy is this one up here. So again, take a close look before I run into a surprise. I wonder if I should be checking the sizes too. If this is really a junk box project from the last repair guy, then he may be putting in capacitors that are close but not quite right. Now up in this circuitry, when you see all these coils and stuff all around it, start thinking that maybe these capacitors are part of the resonance of these things. I don't think that's necessarily the case. The little tiny mica ones, yeah, quite likely. But these bigger guys, they're usually about snuffing out unwanted signals, grounding out unwanted signals and stuff like that. I think this is quite straightforward, really. Just improve my light here. There we go. Cut it right through there. Connection, what do we got here? We've got a point. That's a 0.5. Wow, this is a big capacitor. 0.5, 400 volt, 10%. 0.5. I only have one more 0.5. Really, a 0.5? So he may have put in bigger than called for capacitors, and he may have known enough where to do that where it won't have any bad effect. Right, in the radio manufacturing, they're putting in the smallest capacitor, smallest part they can get away with. Right, they aren't into, let's put a big one in for fun. That's not going to happen. We're going to test this guy right off the bat. I'm going to stop the video and set up the tester a little bit better than last time. Okay. You can see I've got a camera right on the eye. Here it is. Get a good look. Hey, I'm there. Oh, here comes the eye. Goodbye. I'm a little washed out now. So there's a good look at the magic eye. Now what I'm going to do is going to hook up this capacitor. This looks like an expensive, high quality one to me. So maybe it's in good shape. So we're on the 50 volt test setting. Expect the eye to close and open rapidly. Well, it opened all the way. That certainly indicates goodness. Here we go, 150. Yeah, it's still opening. It's certainly showing it's a big capacitor because it takes a while. I'll let it discharge for a moment. And we're going to switch over. We're going to actually measure its capacitance here. 0.5. So again, watching where the eye opens. As I turn the dial here. So that's opening quite wide right at this point here. Okay, let's take a look and see where we're at. You can actually, you know what, you can just look down with the other camera at the pointer. It's dead on 0.5. So this capacitor I took out is actually perfectly good. But you know, there's no way to know until you do something like this. The eye never lies. Well, that's, you know, I'm looking at a whole bunch more work here. What, changing out a bunch more good capacitors? Why is there a 0.5 here? I don't think there's 2.5s in this radio, so I'm going to try to figure out, oh my God, help me now, what capacitor that is. Oh boy. If I'm going to disappear, in video time it'll be seconds. I'm going to disappear and study the schematic, see if I can sort this stuff out. Oh my gosh. So I'm just getting ready to look at the look at something on the internet. I popped this picture up again. It just caught my attention right away. And here, let's take a look at it. What I'm looking at down in this area where I'm getting ready to work, can't see a single capacitor. Well, where are they all? Just, I guess, hidden down under, I guess. Another thing I noticed is the resistors that I'm having trouble with. That would be this one, which is hot, and this one, which is running hot. Look, they're burned in this radio also. Huh. And another capacitor I'm suspicious about is this one here, and it looks like the original is still in there, and it looks like a small electrolytic. So this could be a bypass capacitor around a cathode resistor or something like that. And what else am I noticing here? Well, there's that yellow resistor that looks perfect in this radio. It looks perfect in the one on my bench also. Well, that's all kind of interesting. But it's not going to help me too much. Okay, now, I was really after, what am I really after here? Okay, so we can look at the parts list. here and try to find if there's two 0.5 capacitors. One of them I've already replaced. It's capacitor 47. There it is, 0.5. So let's just go down the line here. Is there a 0.5? Lots of 0.1s. Over here, 0.5. Is that 0.3, 0.2, 0.5, 0.2, 0.3. These are, I didn't notice these before. These are odd sizes. 0.1, 100 volt one. Now here's this other mysterious one. 25. Oh, it says electrolytic right on it. This is the one I was wondering whether it's 25 dot, what it looks like, or whether it's dot 25. It looks like it's a 25. This is a big capacitor. Yeah. So in the radio right now, this might be a 0.05 or something. I'll have to look into that too. Oh boy. Going down 16, 25, and that's it. So there's only 1.5 capacitor in here, and it's 47, and I've already replaced it. So, you know, the next approach now is to try to figure out really which one of these on this diagram is the one I'm after. Ooh, yay. And since the other capacitors have also been kind of relocated a little bit in the back of the radio, can't even be seen in the photograph. Oh my gosh, there's a lot here. Oh my gosh. So I'm pretty sure the coils we're seeing are all these coils. This is one set in one area, this is another set in another area, and this is the last set. Which is which? So this is obviously the antenna set on the front end. Antenna trimmers. This is after the first RF amplifier. So this is a RF frequency, I say intermediate stage, I guess you can call it that. And then this must be the oscillators down here, and there they've labeled the different bands. Kind of weird how this switch looks. Okay, not quite sure how this is working here. It looks like this is a 4-position switch with, I don't know what's going on there. Okay, but normally these two switches would just be selecting out a set of coil and capacitor here. So in here, the trimmers are obvious, but look, see all these little guys here? It could be any one of these. Could be this one. Oh my gosh. How am I going to sort this out? I'm going to have to trace back in the radio to find some identifiable point that I can then come over here and start from that identifiable point and work forward again. Well, I know it has to be in this. It has to be in these coil areas on the schematic. It's not going to be down here somewhere. Wow. Look at this one. Look at this one. See, down here there's a capacitor put between these coils for reasons I don't know, but for some reason they've done this. It's probably a very tiny capacitor. If you come up here, they've just taken a piece of wire and bent it into a certain location. I think we saw this already. In fact, yeah, it's showing it kind of wrapped around this coil. What they're trying to show. Yeah, we saw this earlier. This is the gimmick. So, okay, the gimmick. Right. Okay, back. Let's go tracing. I think that's going to be easier said than done. So we know one side of the capacitor goes to the chassis. Well, that's an important factor. And then we've got this set of coils. Here's the gimmick right here. So we know this is the gimmicky set of coils. Let me just pop up on my own screen the diagram here. And we know the gimmick is found in the intermediate coils. The RF coils. So one of these is the oscillator and the other one's the antenna. Look, these ones have double adjustment. and even more down here. So who's got all these variable capacitors? I am looking now. I'm looking at the diagram here. Well, it's quite obvious. That's the oscillator. It's quite obvious. So this is the oscillator. Oscillator, IF, this must be the antenna circuits. So this capacitor must be on the antenna circuits. Now it's hooked up to this coil, is it? Is it hooked up to one coil in particular? Well, hard to say what it's hooked up to. It's hooked up to a switch terminal. So it goes from a switch terminal to ground on the antenna. I just flip on my own big screen TV here. Okay, I'll put the schematic back up. We'll see if we can find antenna, grounded capacitor. Is there any others in there? Well, no, there aren't. So that's it. There's only one. So this side should be easy. One capacitor. That's a coil. One capacitor in the antenna. Kind of makes sense, you know. It's at the back of the radio where the antenna's coming in. Yeah. Okay. Back to the schematic here. Okay, so you see all the, here's a set of coils, and you see 1, 2, 3, 4 trimmers, but you look at this set, you have 1, 2, 3, 4, 5, 6, 7, 8. So this is clearly that one set I was looking at in the radio with all the trimmers on it, and this is the oscillator. So the one we're interested in is this one. There's only one capacitor. Da-ding, 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 right there. Oh, two. C1A, well this is the tuning capacitor. This is one of the sets of blades on the tuning capacitor, a variable capacitor. That's why it's C1A. C18, this has to be it. Going to ground, this got to be it. C18, that must be it. C18, 0.05. Oh my gosh, he's got a 0.5 in there. 0.05. So would it really matter? Probably not. Probably going smaller would be a problem for sure. Going bigger with something like this, probably not a problem. In fact, the reason it's only 0.05 is because they were cheap. That'd be my guess. So probably nothing bad happened with that there, but 0.05 is what should be in there. 0.05, 200 volt. No question. Okay, I'm always hesitant, you know, and not, you know, the last guy did something. He didn't do it for stupid reasons. He probably did it because he knew it wouldn't hurt, and he had that big 0.5, and so he used it. 0.05, 0.05. That's what a 0.05 looks like. Okay, so I'm going to install that down in there. No problem. Now I wouldn't try soldering to the chassis, of course, because that's a difficult thing. So I'm doing the same thing the last guy did, just leaving the original tail and soldering to it. You probably can't see exactly what's happening here, but I think I'm gonna have to remake that. Now, did I trim this lead too short? Nope. That was close. I should have shaped this before I put it in there. Now, right amongst these coils are going to be some pretty fine wires, especially the finer wire coils down here. And it's as easy as can be to hook one and break it and not even know you did it. Especially when you're doing powerful things, you know, squeezing pliers and stuff like that. I didn't really, yeah, it's okay. Okay, let's try soldering that. Oop, yeah, the lead I soldered to popped off because it was only tacked on. Okay, now what am I going to do now? Now I've got this. Now I'm in the worst of all worlds here. There, give you a better view of the worst of all worlds. Wasn't in my shop yesterday because I was fixing my son's oven. It stopped working. Didn't take long to discover open element, open oven element, lower element. Done this a few times in my life, so oh, that's an easy repair. You just pull out the old element. I opened the guy's, opened my son's oven. The guy opened my son's oven. Where's the element? The element is underneath the bottom of the oven. I've never seen that before. Oh, got to get at it from the back. Take off the back. Where's my soldering iron? What? There's no access. Turns out you have to cut a panel open on the back of this. This is an LG oven. You have to actually cut the panel. When they made the back panel, they stamped it, and they stamped it with the method, you know, where you stamp the metal maybe 3/4 of the way through, but you don't cut it entirely. Then you just flex it a bit and it'll break on that line. But I saw in a video somebody else's exact same oven. They'd stamped it hard enough that that panel was actually only held by a couple of little tabs. It was kind of neat how they did it. If it works, all you do is go snip, 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 and this panel will pop off. It's not that it was screwed on. It was still part of the original panel. But in my case, no, it's not stamped hard enough. In fact, the stamping, you couldn't even see it. So I actually, where is it? Cut through the back of my son's stove using this. Where are you? Here you are. Yes, like that. Nipping my way through it. It took like a half an hour to cut this panel out. Wow. If I made a video, I'm sure people would have been freaked out about what I was doing. Well, actually, I did take a couple of photographs. So here's the first one. You can see I've taken off the main back of the oven, and there's a second inside back. There's the upper element sticking through. See, this huge panel here, you'd have to, I don't know how you get this one out. This one down here comes out through this panel. There's a close-up look of my hack job hacking it all off there. And there's the element that we took out with the damaged part to it. I got it. How about this one down here? Yeah, that's it. Okay, one done. One done. Okay, do the tough one now. Maybe if I do these, they will disappear deeper down, and they'll be kind of out of the way. I'll have a little more access over here. So okay, so we're going for these ones next. 3 of them, all involved in this RF. After the first RF amplifier tube, before the mixer. 1, 2, 3. They're all, well, I don't know what's going on. Yeah, this is the grounded end, and the other end is the business end. So they got two of these capacitors hooked up to that tube. That should be a real good giveaway. It's right on tube. Oh, that's a giveaway. Okay, this should be easy. Let's see what we can find out now. Okay, let's go back. We're going to look at the schematic some more here. Actually, that wasn't my meter. That was my soldering iron. He's happy. Okay, so now we're talking about which tube are we talking about? We're talking about the second one. I'm not going to rely on my brain here. I'm going to look at a diagram. We're talking about this tube, the RF tube. Very good. That all makes sense. The RF tube. So we're talking about this tube. So we should be able to find a capacitor. Here's one. Right on pin 4. This is the screen. Yep. And then we have this one. It looks like more like a bypass, this one. That's only 2. This one, on the schematic, it's right next to this tube, but it could be anywhere on this line, way up in the radio even. Way far away. So okay. Yeah. So one of them is tied to the switch, but the other two really do go to pins. I'm going to figure out the pin number. Maybe these are fakes. Wow, that's really hard to tell. It's really hard to tell. Maybe this will help a bit. So I'm trying to spot the key on the tube. Okay, I see it with my own eyes. So we will count from the key. 1, 2, 3, 4. So this is on 4. And we count back from the key. 8. This one is on 8. I think 8. I don't know. 8 and 4. 4 and 8. Okay. Let's go back and see what the schematic says about that. 4. So, that could be it. Maybe they put this capacitor close to this tube because this is the first tube and it needs the most quieting. Maybe physically they've actually done that. So we'll assume one of them is 21. And the other one was pin 8. There's 8, so that's the other one for sure. So 19 and 21. I think that's what we got. And the third one, I don't know yet. The third one's this one, I bet. I'll bet you it's this one. It could be that. Well, let's see some sizes here. The sizes, like this might be a little mica. This might be a bigger one. So we got 19, 20, 21. 19, 20, 21. I can remember that, I think. 19.1, 20.05, 21.05. This is a 100 volt one. Now that's a hint as to what this is doing. C19, let's look again. Yeah, C19 is a bypass capacitor on these cathode resistors, which are switched through this thing, changing the biasing of this tube. So just something really curious about this radio and the way it works with different tube biasing. I might as well use the word biasing of all sorts here between bands, like this switch and this switch. Maybe there's even another one in here doing stuff like that. Very curious to me. Okay, so now we know these two, and we think we know this one. This one is hooked up to a terminal. Pictorially, it's the last terminal in a row. And what is this line? This line comes over to, this is the B plus line. So the B plus, this is going to the plate. So the plate is selecting different sets of coils. I think this whole ring rotates. and this pointer selects 1 out. So in effect, and this is, I don't know. I'm not sure. I think this is a weird shape over here too, where they show it kind of looping around here. Okay, I'm not quite getting these switches yet, but I'm getting closer all the time. There's a resistor in there. Was that? No, what's that? R4. What is that? I'm just curious. Oh, how do you like that? Red. So I think I've spotted this. But and there's another one over here, R5. I'm just curious. 100 ohms. What difference can it make? 100 ohms. Might have something to do with the Q of these coils, trying to reduce the Q a little bit or something. I don't know. Again, it isn't. I see these kinds of things. I think the radio designers designed the radio as best they could, and then they start fiddling with it, sticking in stuff here and there. Got an oscillation. Let's whip a capacitor over there. Hey, that stopped it. Great. You know, that kind of stuff goes on, I think. Okay, so let's see if we can pick off C20 in particular. We'll leave these two for now. C20 to the switch. Is there anything else connected to... Oh, there is. C22 is hooked up to this switch. So I got one side. It's probably switch 3, so I think this is section 3 or segment 3. Switch 3, maybe it's switch number 3. I'm wondering if these are back to front. Who knows? So you might think this, I don't know, who knows? Usually, yes, they would be back to front. On either side of the same wafer. I think I'm just going to have to look at this on here just like I did. I don't think I'm going to be able to prove it much further than that. Unless I can go back and I can spot R7 quickly. Maybe R7's right near there. Okay, let's go look. Wow, that was a lot of running around on the schematic there. So I see a resistor. It's not a 22. And so this guy here, hang on, a bit of bad camera work. This guy here is the guy I think, see, he's connected to the switch here. Oop, connected to the switch. That's a 0.05. 0.05. I'm just going to glance myself at the schematic here. And that one, C20, is 0.05. If I'm going to replace this, I'm not going to do this common ground thing. I don't need to, because I'm using new capacitors with lead length on them. So this can be installed somewhere else. I was hoping in that photograph we glanced at it would kind of show the angle on it. It wasn't even visible. So this one could go down, and like the other two, you know, one can go down there. It's pretty tough. Wow, it's tough in there. These are fairly large physical capacitors too. It might be a little tough to tuck them in certain spots. These ones, mine are a little smaller. If I do it one at a time, is there a problem with that? Am I going to put one in and then realize, oh, that's just made it impossible to do the rest? There's some wires down here. You moved a little bit. Don't move wires very much. And this wire down here looked like it was once dressed right along the chassis, and it's been tugged and moved around, so it's all spaghetti now. Move that one out of the way there a little bit. And there's no wire tail down there to solder to. You're looking at soldering right onto the chassis. Oh my gosh. Oh, you know what? I see another solder point further in. Further in. Wow. I don't know if I can get that on camera, but way down there. Way down, right at the bottom of the screen. You can see something with a touch of solder on it. Okay. Not this one. This one, way at the back there. That's probably where that capacitor went. Wow, can I duplicate that? Oh, I don't think so. I can't imagine it. So maybe what I need to do, I need to do the 3 capacitors tied to ground. The same thing he's done here, except flip it around into a more appropriate location. And get one of these connected to ground, and then the other 2 can go on the lead, on the grounded lead. They could potentially all go to this thing down here, but it's really tough to get down there. So there's lots of reasons why the guy did this. Now there's other, I'm sure, other ground terminal spots. For instance, where this white wire goes, right? You can't see it down there, but the white wire goes down to a grounded terminal. So there's a grounded terminal right down there, right on the tube. Is that definitely a grounded terminal? Yes. I can see the connection to the riveted part. Huh. Yeah, these are the easy ones. So perhaps I can get one installed right on the tube socket, come around and catch the ground on the tube socket, and the capacitor can sit down on the base here. That'd be one out of the way. Then the next one, this one is connected so close it can't get to ground easily over here. So this one we would want to hit ground somewhere else, and I'm sure I've got options here. The grounded terminal right up here. This resistor lead is grounded. Absolutely. So it'd be easy then to flip a capacitor from here over to here. So this one could go over there. So this one goes on the tube socket. This one flips over this way. And this last guy, well, he can go down on the tube socket too, down here. He's got his choice. He can go either place. Either place. Okay, then order. In what order do you do these? Okay, we can get rid of these grounded. I'm using my old cutters. You see the gaps in them? That's my wife cutting coat hangers years ago. That's why you never see me use these cutters. Including right now. I bit my tongue when I caught my wife cutting coat hanger wire with it. I bit my tongue. I was yelling so loud. No, no, she didn't know. Oh, what's happened here? This guy's come right off. Well, how do you like that? He is tacked on there. Now, just how well it was doing, I don't know. So it came from down there. Okay, I'm just going to cut this here. Well, we got one. Oh, he's taking some pretty bad solder strikes. Soldering iron hits. Wow, and just to top it off, it's a Hunts capacitor. This one's bad in every way you can think of. Let's check them out right away. Let's check out the Hunts. Over to the tester we go. As soon as I figure out what I'm doing here with cameras and whatnot. My tripod is so tangled up in cords here. So you just watch from this distance. I'm going to let you watch from this distance here. That guy out. Does the Hunts live up to its reputation? Can't get there. Too tangled up in wires. There we go. Oh, it opens right up just fine. So that's at 250 volts, and you can see it's no longer opening up. And a brand new capacitor like the one I'm going to install, you could put this right up to 450 and this thing pops right open. So of course there's some leak in here, but it's not terrible. On the other hand, where is it? It's up in those front end circuits. Maybe a little leak is maybe the radio is very sensitive to a slightly leaking capacitor. And what size was this? It must be 0.1. That can't be a 1. It must be a 0.1. Now I'm going to get too much on the go here. I'm going to start losing track of who's who and what's what. So, the one we've removed, I think I'm going to install now. And it's come from ground terminal to here, and I sort of planned out putting it from here to there. It's on pin number, I can see these better now, pin number 8. I'm going to double check on my own here quickly. Pin number 8 is the C19. C19 is a 0.1. Just what was in there. Perfect. 0.1. Okay, it'll be at a 0.1 here. Yep. Our plan is to put it something like this. Okay. Go to the grounded terminal over here. It's not going to work, is it? Okay, that's going to work. It's easy to feel overwhelmed. Lots of things in life are overwhelming. And unfortunately, as human beings, when we get overwhelmed, we get really uncomfortable. And can't think right. That's part of what makes us feel uncomfortable, because we already know we're not really thinking right. Yes, So what I do, and I think what everybody does, is just kind of calm down and start taking it one step at a time. Don't work in an overwhelmed state. Okay, so that's quite solderable there. Let's push it down towards the terminal. I think I'm going to solder that. I'll have an easier time with the rest of it. Okay, now can I grab my soldering iron through all these wires and cameras and everything? Yes. Watch it, man. What's going on? My soldering iron's sleeping. What? God, for crying out loud. I'm supposed to wake up when you shake it. So I got my soldering iron's got it's got a standby. It drops its temperature, and then it's got a sleep. It goes to sleep. Can't wake itself up. I guess maybe that's the definition of sleeping. just gotta reach through all these cameras here again. Really. There we go. That's one end. Now the other end. So I'm gonna nip this white guy out of the way. He'll be next on the list. Wow. Okay, so the lead is really easy to short out against parts of the structure in here. Sure that's a 0.05. So this is the one. See, I'm getting myself confused. This is this one right here. Don't get confused. I guess the worst kind of confusion is the kind where you don't realize you're confused. I think we probably go through life like that. Frankly, we're confused non-stop about everything, but you got to get on with life. So we're built to live with a certain amount of confusion. That's absolutely true. Our decision-making capabilities are enormous. We are very, very good at making the right decision with insufficient information. We're really, really good at that. Sort of living in the chaos. It's great to be a human being. Inside my head right now could be the most complicated thing in the universe. Same thing inside your head. If you wanted to look and find the most fantastic complicated thing that exists in the universe, it could well be what's in our heads. Easily. Okay, dolphins might be a step ahead of us, actually. Their brains have twice as many folds as our brains, and there seems to be a direct relationship between how powerful your brain is and how many folds you have in it. What they're lacking, of course, is hands. They have no hands, so what are they going to do? They're going to be stuck in the ocean. That wasn't a good decision to grow fins. Much better that we decide to grow hands. Good idea. I see some other animals are working on the hand thing too, but we're way ahead. I gotta use my other hand. Talking about hands. I don't think anybody's catching up to us. Ooh, a flying piece of solder. Get on there now. So what are you seeing, the back of my hand here probably? Oh, this is bad, 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 bad. Bad, bad, bad. What happened here? Okay, that's going to hang on there. So the weather here in this part of Ontario, I think it's true right across Canada, in fact, probably most of the upper states too. It's like somebody threw a switch September 1st, summer turned off and fall turned on. And I've been waiting here for the rest of summer to show up. I don't think it's going to show up now. Like summer turned on July 1st and turned off September 1st. It's not very good snappy fingers. So that's one done. Well, it's two done. Two done. Holy smokes. How long have I been going here? Oh, only half an hour. So the next one. I'm confusing myself already. I want one to go from here to ground. It could be down to there. Let me just hang on one sec while I double check everything. Make absolutely sure that I'm only confused to a minor degree. So coming off the coil, C20 is 0.05. That's what was in there. Okay, 0.05. 0.05. 0.05. So somehow I think making the ground connection is easier. I could still use this wire here. There's actually a hole in the terminal I can push the lead through. So first I'm going to try to pull this wire off on the basis that it may be just tacked on there. Now it looks like it's wrapped around. Wrapped around anyway. I'm not desoldering it, but I can tell it's wrapped around. So we're going to cut it right off. Goodbye to you. And we want to use this for two capacitors, so this is one of them. So let's stick it in there. We're going to get two of them shoved through this hole. One, and then that would come up here, attach right in there. Now there's such a high potential for shorting in there. I'm going to try to reduce that a bit. Good. Then we want to get onto that terminal. Which terminal? Can we make a mistake here? Take a really close look at that situation in there. Something to pay attention to. Getting better with the camera than I can with my on my eyes. Yeah, right in here. So there's the terminal. Oops. Yeah, there's a red in the background there. There's the terminal, and then there's this big metal bracket just sitting right there. Holy smokes, those are close. Wow. Are they in contact? I don't think so. Surely you wouldn't want that in contact. Wow, that's a tricky spot there. Wow. Bend these forward a bit. Wow, yeah. What's tricky about it is you can't really see. Well, I mean, I got a camera shoved right inside the radio to see this. Wait a minute. What? Does that actually attach? No, that can't. This is a switch terminal and a bracket, just extremely close. Okay, so I'll fiddle that in there, and then take another close look at it. Okay. See what that looks like. Well, I got a grip on it. The bare metal I'm going to cut away. That's the excess lead, so we just solder it in there. That resistor is not the most healthy looking one either, is it? And there, right down there is the red. It looks dirty, but okay, probably. Now we're going to try to solder in there. I'm up on my tippy toes here. Uh-oh, I heard a cat. They're coming for me. That's good, it's taking. There. I think I got it pretty good there. I don't want to do the other end yet. Let's just check it and see. Oh yeah, that's as stiff as can be. Get rid of the excess here before I forget. There we go. Perfect. Now we're going after this one. This one, Mallory, plastic cap. Made in the USA. Here he comes. Point. Not sure what that is. Whoa! Oh man, live. Peanut. Come on. Peanut. What? Come on. He's just saying out. And he knows coming in here isn't going to get him outside. He wants me. He knows he's got to get me to go out. He knows this. No, no. No. You want to go in the garage? How about that? You want to go in the garage? What do you say? Okay, come on. Come on. Okay. I think I'm going to have to stop for a little bit here and play with my cats. So, okay, we'll just leave this hanging, right, just like this. Yeah, I hear ya.